we're now asked to find all of the solutions to the equation sine x plus root 2 equals negative sine x on this interval. Well, that's 0 to 2 pi. Include the 0, don't include the 2 pi because of this bracket here. That's just one unit circle. So immediately that tells us we're not looking for the general solution. The general solution involves that stuff where we put plus 2 pi n to each of the solutions. Now we only have to find whatever solutions we have from 0 to 2 pi. Our method remains the same. Let's try to isolate sine x and then solve for x, the angle. So let's drag all of the sine x's together. If I add sine x to both sides, I get 2 sine x plus root 2 equals 0. Now I'll subtract root 2 from both sides, and that'll give me 2 sine x equals negative root 2. Finally, if I divide both sides by 2, I get sine x equals negative root 2 over 2. I've isolated the sine. Now, normally we'd say x is equal to inverse sine of root 2 over 2, and we get one solution. But instead of going to this, I'm going to go to my unit circle. So let's look at sine x from 0 to 2 pi. 0 max, 0 min, 0. You see how that work we did when we graphed these sine functions was so important to give you a background in this. So if I make this y1, I say, well, y1 or f1 of x is sine x, and y2 is negative root 2 over 2. That's a horizontal line. I'm going to get two solutions. Take a look here. Here is pi and here is 2 pi. So I'm expecting two solutions after the pi line. So I'm expecting two solutions between pi and 2 pi, or in quadrants 3 and quadrant 4, because here is 3 pi over 2. So I'm expecting one solution in quadrant 3 and one solution in quadrant 4. Now, that's how you would look at this if you graphed the sine graph. What if we looked at it from the unit circle perspective? If I draw my unit circle, quadrant 1, quadrant 2, quadrant 3, quadrant 4, I know that sine is the y, A, S, T, C. This is the ratio. Sine of an angle is a ratio. Where is the ratio negative? Well, sine is the y. It's positive up and negative down. So I'm going to have angles in the third quadrant and the fourth quadrant. But you knew that. We just showed you why that would happen. All right? So the angle is here. Now, when I say the angle is the third quadrant, whoop, there is x, and whoop, there is x as well. They're huge angles. Now, what are they telling us once I draw my triangle? Now, notice, the triangle is always going to involve the x-axis. Do you see this? This triangle has one side of the x-axis. This has one side of the x-axis. Why do I mention that? If you draw this angle, this is the terminal side in quadrant 4. Here's the terminal side in quadrant 3. It's a unit circle, so let's make them 1 and 1. Some students draw this as the triangle here, and I say that doesn't involve the x-axis. The triangle has got to have its right angle right on the x-axis. So I've got two triangles. Once I draw my terminal side of my angle, I've got two triangles, and each of them has one of their sides on the x-axis. So I think I'm doing well. The sine is negative, so that's the y. On a unit circle, sine is the y, and it's negative. If I put that there and that there, and it's a unit circle, I know that this is plus root 2 over 2, and this is minus root 2 over 2, which forces this little wedge of cheese here to be pi over 4 and pi over 4. So the question now becomes, what's this monster angle? Well, here is pi, right? We could call that 4 pi over 4. So we go 1, 2, 3, 4 pi over 4 plus 1 more. So x is equal to 5 pi over 4. Here is 2 pi, right? If we go all the way around the circle, we're going to 2 pi, which is the same as 8 pi over 4. So I'm going almost all the way to 8 pi over 4, but I back it up 1 pi over 4. So x is 7 of these pi's over 4. And there are my two answers. Notice one was in the third quadrant as predicted, and one was in the fourth quadrant. I got my two answers. Now, do you have to draw that sine graph out? No, that's for instructional purposes only. But never forget that when you have an equation, if you graph this one and graph this one and look at where they intersect, you have found the solution to the equation.